Good evening, everybody. I said good evening.
Good evening, sir.
Good evening, man. Make sure your video is on. We're starting the class now. Everybody, make sure your video is on. We are going to start the class now. Yeah. Please, please. So, Lakshita, Soumya, Ritika, Karthikeyan, Lohita Shri, everybody, please make sure that your video is on. Karthikeyan, why is your video still not on?
Sir, 1 minute, sir.
Make it fast, please. We'll start the class in any minute. And if I remember correctly, in the last class, we started speaking about law of conservation of energy. Am I right? And we ended the class with one question, one swing question, where I told you how to calculate maybe the velocity or the height or any quantity with the help of law of conservation of energy. We'll solve more questions like that in the practice class, but today let us proceed further in the syllabus. Okay? Today, if everything goes fine, will be the last class for work, energy and power, and we are going to study one of the very important topics. This topic for sure will come in the school exam for 3 mark or 5 mark question, which is the derivation of collisions. It's a kind of confirmed question in the school exam. So understand the collision topic well. If you are failing to understand this topic, you will definitely have problem in the class. Okay, but it's very simple, interesting topic. Let us make it clear, and you people should focus in the class and understand whatever I am teaching today. Okay, if any problem at any point of time, stop me and you can ask me anything if you want to ask. Meanwhile, Ritika, may I know who is this Ritika? Is this the first class for you?
I have joined offline before.
Okay, Ritika, you were in that batch, right?
Yeah, sir, I changed the...
Oh, you have changed the batch today.
Yeah.
Okay, fine. So, on your video, if you are coming to this class, the video should never go off. Okay? If you are having video off, then we will put you in waiting room. That is the rule for being in this class. Yeah.
No camera.
Then make your camera ready. From next class, you have to come with the video on only. If you are attending online class, the camera should not go off. Is it clear?
Okay.
Okay, what about Karthikeyan? What happened to your camera, man? Shall I put you in waiting room? When, man? People are waiting. Make it fast. Right. So, let us start the class without wasting any further time, and let us start the class today with some questions that I am going to ask you. I am going to put forward some questions in front of you, and the answers of those questions will be given by the end of the class. I'll ask and I'll keep it as a suspense. What is the answer for that question? You can give your tries. Okay? The first question that I am going to ask you is, I am giving a scenario to you. Think and then give an answer. Scenario is, there is a car going at a speed of 40 km per hour. 40 why? Take 80 km per hour. Okay? 80 km per hour car is going. In front of the car, there is a bike. And the bike is going at 60 km per hour. So, I am driving a bike at 60 km per hour. Behind me, a car is coming. At what speed? 80 km per hour. Obviously, the speed of car is more than the speed of the bike. You agree to that? What will happen in some time? Overtake if it is going differently, no, coming behind me. It will collide, it will hit me. I am going in front, it will come and hit me from behind. Do you agree with me? So, scenario number one is, person A is driving the bike at 60 km per hour. A car comes behind him with a speed of 80 km per hour and hits the bike. Obviously, bike will fly, common sense, and some accidents will happen, injury will happen, It's a collision. Case 2. In case 2, bike is standing and I am going to start the bike. I just put my leg across the bike, I sat on the bike, and before I start my bike itself, a car came, same car, he wants to kill, and the car is having same speed 80 km per hour, hitting me. I will fly. In which case I will have a severe injury. When I was traveling at 60 km per hour, in 60 km per hour somebody is hitting me, or I am traveling at 0 km per hour, I am at rest and somebody is coming and hitting me. In which case the injury will be more. What is your opinion, Mr. Guru Charan? Yes, Guru Charan? Your opinion I am asking. First case means which case? In the case of 60 kilo. Okay, okay, fine. Anybody else here? Sadhana, what is your opinion? When he was at rest? Oh, strange. Okay, anyhow, we'll discuss that. What is your opinion, Shrestha? First case. What is your opinion, Kirtana? First case. Madhuvanti. First case. Soumya, what is your opinion?
Sir.
Yeah, first case or second case? You heard the cases, right?
Yes, sir.
Which case will have more injury? First case or second case? First case is when the bike was moving at 60 km per hour, hit by a car at 80 km per hour. Second case, bike was at rest, hit by a car at 80 km per hour. Which case will have more injury? A or B?
B.
B you are saying.
Yes.
Okay, yes, supporting Sadhana. Sadhana itself doubtful, one support came. Fine. Manager, what is your opinion?
Sir, I think it's first case.
First case. Saranaram, what is your opinion?
Sir, A, sir.
A. Okay. Raitanya, what is your opinion if you heard the question right?
Sir, A, first case.
Okay. Lakshita, what is your opinion?
First case, sir.
Generally, this kind of question when I am asking, there is a common sense answer, right? And obviously, generally that common sense answer is not true. It happens, no? I am not saying you are wrong. We will know the answer at the end of the class. If everything goes fine, if I am able to complete all my topics, it's a big topic today, then by the end of today's class, you will come to know which case you will have more injury. There is a physics behind that. And that physics only is called as collision. Give the heading as collision. Give the heading as collision. Now, if I ask you in layman's word, what is collision? Kirtana, what is your answer for collision? Yes. Right or wrong? Give a try. Yeah.
When something happens when two things collide.
When two things collide, it is called as collision. Okay, okay, fine, fine, fine. Good, good try. Yes, Muhammad Arshad, what is your opinion about collision?
Sir, colliding of two objects, sir.
Okay. What is the definition of sitting? Sitting of two people is called as sitting. Okay, yeah. Fine, Kashika, what is your opinion? What is collision?
The interaction between two bodies and lead to collide, sir.
Interaction between two bodies. Okay, I am asking question to everybody. Just tell it is yes or no. All of you can unmute yourself and say yes or no, okay? Question is, for two bodies to collide, their physical contact is mandatory. Yes or no? Online people, I think you have mouth. You have, yes. It means the answer is no. Okay? So today you will understand that collision is possible even if two bodies are not in physical contact. Write the definition first. Collision is phenomena. Collision is a phenomena. Collision is a phenomena where, Lakshita, I hope you are in the class and not talking to anybody. Please be in the class. Yeah. Don't miss writing what I am giving the notes. What I told?
Where
Collision is a phenomena where I told her. Okay. Where there is an interaction of, where there is an interaction of, where there is an interaction of forces, exchange of energy and momentum, comma you put, exchange of energy and momentum, exchange of energy and momentum with or without physical contact, with or without physical contact, with or without physical contact. Yes, please.
Sir, can you repeat some interaction?
Yes, Mr. Lalit, today you are in online. I will repeat, no problem. So, I told interaction of forces, exchange of energy and momentum, with or without physical contact. That only I told, no? With or without physical contact. I hope you wrote, Mr. Lalit.
Yes, sir.
Okay. Now, don't think collision as hitting of two objects. That's what you are thinking till now. When you are hearing the word collision, what is coming to your mind? Two objects are banging each other. That is collision. You are thinking like that. No. It is also a collision, obviously, but collision requires exchange of energies, momentum, and there may be no physical contact. The best example is Rutherford's gold foil experiment. Do you think that alpha particles which was bombarded on a gold foil ever went and touched the nucleus of the atom? Never. But it got deviated? Yes. So, if this was the nucleus, it came till here, it turned back also. Exchange of energy happened. Here it had maximum potential energy, you know this? Maximum maximum kinetic energy and minimum potential energy. As it went towards, here it got maximum kinetic energy, maximum potential energy I mean, and kinetic energy became 0. Once again it turned back and went there. So, the potential energy started getting, that is kinetic energy started getting converted into potential energy. At this point, all of kinetic became potential, and once again potential started becoming kinetic. Exchange of energies happened or not? Happened. But there is no contact between the alpha particle and the nucleus. One more example I will give, more relatable example. You have a magnet. Bring another magnet of north pole. North will repel each other. Exchange of energy and forces is happening, but there is no physical contact. It's a collision. So, don't think that for collision you need bodies to interact. It's not needed. It may or may not be required. Okay. Now, this collision is classified based upon two parameters. First parameter on which the collisions are classified is known as conservation of kinetic energy. So, first, based on conservation of kinetic energy, collision can be classified in three categories, which is the most important part of this chapter. First category is called as elastic collision. I should say perfectly elastic collision first. Perfectly elastic collision. Second type of collision is called as inelastic collision. And third category of collision is called as perfectly inelastic collision. Perfectly inelastic collision. So, collision can be perfectly elastic, collision can be inelastic, and collision can be perfectly inelastic. Let us understand one by one. I will give time for writing, guys. Please focus on learning now. this video is going to be there, I am going to be there. So writing part is anytime can be done, but understanding can happen only when I teach. So please don't focus on writing, focus on listening. Okay. So if kinetic energy of the object before collision and kinetic energy of the object after the collision is same, then the collision is perfectly elastic collision. Is it possible? Possible theoretically. Practically, I don't think it is possible. Energy will be lost always, right? If ball is hitting the ground, sound will come. Friction will be there, heat will be there, some energy will be lost. If I drop the ball from here, it is impossible for the ball to once again come back in the same height. You know this? It will come little low only, little low. Why little low? Some energy will be lost in sound, heat, friction, all these things. So whatever energy the body is released, it will not gain the same energy, it will have little lesser energy. Once again it will go down, it will lose more energy. So energy is lost for sure in the practical scenario, but theoretically it is possible. Second, in elastic collision, what will happen? Kinetic energy before the collision is not equal to kinetic energy after the collision. Almost all the collisions that you see around you, everything is inelastic only. Bus is going and hitting a truck, truck is going and hitting a car, car is going and hitting a bike, bike is going and hitting a cycle, cycle is going and hitting a human being. Human being is going and hitting another human being. Whatever we are hitting each other, all these hitting and collisions are inelastic collision. Some energy is lost. So energy is not same before and after. Very common example. I hope you are getting my point. So all day-to-day collisions that you are seeing around yourself is what collision? Inelastic collision. Now what is the meaning of perfectly inelastic collision? Example. Guru Sharan is running. Okay. He has some energy because of its motion, velocity, half mv square minus u square if u is 0, half mv square. And Pritish is also running. Pritish jumps on Guru Sharan while running. I hope he is alive. And then they both run together for some time. Don't imagine, man. Just for theoretically I am saying. So, energy initially of Guru Sharan and Pritish was different. But after a few seconds when he jumped over him, then they both were moving in the same velocity, right? So, energy combined for both of them. Can I say like that? Their velocity became same after collision. Can I say like that? Velocity of Pritish and velocity of Guru Sharan may be different before collision, but after collision, it is same for them. One more example I will give you, more practical example. There is a skating board kept here. Okay, I am a professional skater, not really, just for this example. I am running and jumping on the skating board, and I along with skating board go for some distance. Looking good to hear, but not possible easily. So initially skateboard is at rest, no energy. I have some energy because of my velocity, but when I jumped on the skating board and me, we both got same velocity. This kind of collision is called as what collision? Perfectly inelastic collision, where the velocity of both source and target becomes what? Same. Is it clear to you the examples? Perfectly elastic collision example, if you ask me, literally nothing, but for assumption we can take the atomic reactions, what I told Rutherford reaction, now that can be considered to be perfectly elastic. So whatever derivation we will make in 12th standard, in 11th also chemistry you had a basics of that. In 12th in physics also we will have Rutherford's experiment. There you learn all the equations of kinetic energy, potential energy, everything you will learn. That time we will assume the collision to be elastic collision. So example of perfectly elastic collision can be what? The subatomic interactions I am writing. Subatomic collisions. Just example. Because why we are taking them? For the easiness of making equations. Inelastic collision can be, what is the example it can be? Day-to-day collisions, whatever you are seeing. And this for this example, anything you can write by your own wish. There is a wooden plank hanging. Have you seen RRR movie? RRR, long back. That boy, that person, what is the name? Ajay Devgan's son, Ramcharan Teja, his name is Ramcharan, some hero, I don't know. That guy hits the bullet. Oh. It hits the gun and the bullet goes. Actually, it makes the hole and goes through the plank, if I am right. Whatever. If it is not making also, if the bullet goes, hits the plank and the bullet moves together for some time, that is a perfectly inelastic collision. Is it clear to you? So, example can be bullet attaching with a, yeah, tell me man.
Sir, can you again explain the perfectly inelastic question?
I explain one second.
Collision.
Yeah. And moving together, yes. So, I said, Lalit, if the velocity of both the objects becomes same after collision, the collision is called as perfectly inelastic. Like I gave example, like suppose you are running and you are having some velocity and somebody else is also running, he is also having some velocity, he jumps on you or you jump on him and you both go together for some distance, then both of you will have same velocity, right Lalit?
Yes, sir.
That is called as perfectly inelastic collision. Understood?
Okay, sir.
Thank you. One more important thing.
Sir,
Tell me, man.
sir, if after the collision, the two objects will have same energy, you know.
Same velocity, energy you should not say, because energy is depending on mass also, no? If Shrish is jumping on you, Shrish is having less mass, you are having more mass, then how you will have same energy? But you will have same velocity, isn't it? If I am jumping on you, I have more mass, you have less mass, then how we will have same energy? I will have more energy than you, but we will have same velocity, right? If we are able to move some distance. Understood, Mr. Lalit?
Yes, sir.
Thank you. One more important thing before I close this, which you will not understand, that is coefficient of restitution. I will explain that today. It will come in the derivation. Small e is called as coefficient of restitution. Restitution. What is that? I will explain to you when I start deriving. But for the case of perfectly elastic collision, the coefficient of restitution is equal to 1. Here E is less than 1 and more than 0, and in perfectly inelastic collision the value of E is 0. Is it clear to you? The value of E in all the three cases I told you. I know most of you who are not knowing about this term are not knowing what is this E, but today you will understand by the end of the class. First you copy this fast. Take 2 minutes of time and copy this. Don't take much time. Take 2 minutes of time and copy it fast, please. Whatever classification you are writing, it is based upon the conservation of kinetic energy. Remember that. This is the base of classification. Take the attendance meanwhile. Kirtana Rajashekar is absent, right? Yeah, she is not. So now we have 3 Kirtanas. Anu Kirtana, Kirtana Rajashekar, you are M Kirtana.
Yes.
S Kirtana. M Kirtana, nobody is there. Okay. Kishore. Let me know if you are done. Yeah. Any example you can take. Bouncing of ball, car hitting a bike, anything you can take. I hope you are done. No? Make it fast, please. Today is the long class already. Don't make it more longer. Shall I proceed? Online people, can I proceed?
Sir, 1 minute.
Make it fast, please. Lalit, shall I?
Yes, sir.
Okay. I am moving ahead. If you have missed something, later you can copy. Okay. Next classification is based on direction. Based on direction. So, based on direction, there are two kinds of collision. One is called as one-dimensional collision. One-dimensional collision, which is also called as head-on collision. It has another name, head-on. And second is called as two-dimensional collision, which is also called as oblique collision. Two-dimensional collision. It has another name, which is oblique collision. Luckily, you don't have any three-dimensional collision. Okay, it will become more complex, obviously. So, what is the meaning of the word one-dimensional collision? See, very simple. In your childhood, 9th standard, you have learnt M1U1 plus M2U2 is equal to M1V1 plus M2U2. Remember that? I think everybody learned this. Hope you remember also. M1U1 plus M2U2 is equal to M1V1 plus M2V2. How you learnt? You know this? You learnt under the heading of law of conservation of momentum, which was taught in laws of motion chapter in 9th standard. So, in laws of motion, under the heading of law of conservation of momentum, you have already learned it. That only is called as oblique, one dimensional. That is, one object is there having mass m1, velocity u1. Another body is there, mass m2, velocity u2. And assuming that they are in same line of action, single line. After, obviously, if u1 is more than u2, then only it will hit it. If u1 is more than u2, it will go and hit it. After hitting, after their interaction, what will happen? The velocities may change. It may become v1, it may become v2. Mass, if it is not braking, it will remain same. It may break also. In JEE, we will have braking conditions also. In school, it will not break. So, in JEE, it will break. So, now what happened? Before the collision and after the collision, direction is same. This kind of collision is called as what collision? One-dimensional collision, where before the collision and after the collision, the direction of the objects remains same. Second possibility is there. One body having velocity u1, mass obviously m1. Another body having mass m2, velocity u2. Now you see they are not having same line of action. If you see clearly, it has center lying here, it has center lying here. They have some difference in their centers, right? This is called as impact parameter B. It has a name, small b. What is B called as? Impact parameter. What is the meaning of impact parameter? It is the center to center distance between the two objects. Are you feeling what is this center? This is our center. So center to center distance is called as impact parameter. So if two objects are having some impact parameter, after it goes and hits, what will happen? One object may move like this, another object may move like this. So what happened? Their directions changed, isn't it? It became V1, it became V2. This is M1, this is M2. This happens in real life. In billiards game, have you seen it? Pool game. You will, the hole is there, ball is here. You will hit in such a way that the ball will hit and it will go that side. Skill is there for that. And obviously physics is there for that. Today you will understand the physics also. This collision is called as oblique collision, where before the collision it had one direction, after collision some other direction. But in single plane, are you seeing that? If you are playing billiards or carom board and your coin flies and goes outside, it is three-dimensional collision, isn't it? But if it is on the board, it is two-dimensional, only in the plane it is changing. Are you getting my point? So I am talking only about two-dimensional, not a three-dimensional cases. So here also the board is there, the balls are there, I am hitting, it can either be one-dimensional if it goes straight, or it can be two-dimensional. There is no question of three-dimensional here. One thing I will ask you, for an object to undergo two-dimensional collision, that is oblique collision, impact parameter should have a value. What should be that value? Do you think any value it will hit? Do you think any value of impact parameter will make the collision? No, obviously no. One object is here, another object is here, going like this, it will hit, eh? No, right? Because impact parameter is too much, isn't it? So what is the range of impact parameter for oblique collision? Any idea? Radius. It should be more than 0 for sure. Can I write it should be less than R1 plus R2? R1, R2. If it is R1 plus R2 exactly, it will glaze. Glaze means it will touch like this and go. It will touch and go. It is called as glancing or glazing. I am not talking about that case. But if it is having less than this value, then only you can see what collision? Oblique collision. In the exam, if they ask you, what is the impact parameter required for oblique collision? The answer is less than R1 plus R2 and more than 0. And here what should be the impact parameter in the case of one dimensional? Is it clear to you? If yes, copy it fast. Make it fast. Less things to write.
Sir,
Please ask me, man.
so head on, I cannot understand.
Which one, man?
Head on.
Head on. Head on means one dimensional, man. It's a name for one dimensional. One dimensional collision is before the collision and after the collision, this direction remains same. How is it possible? If one ball is there, another ball is there, and their centers are in the same axis. If it goes and hits it, what will happen? After hitting also, they will have same direction. Their velocities may change, but direction remains same. This kind of collision is called as one-dimensional collision. One-dimensional collision is also known as head-on collision. Are you getting my point, Lalit?
Yes, sir.
Make it fast. Yeah.
So in 2-dimensional position, both the velocity and direction will change.
Both the, obviously. In that case, only velocity will change, direction will not change. Shall I proceed? Sai Varshini done? So I hope by now everybody is clear in the meaning of one dimensional, two dimensional, elastic, inelastic, perfectly inelastic. See, elastic only is sometimes called as perfectly elastic also. Don't confuse in that, okay? If I use the word elastic collision, it means it is perfectly elastic collision. So elastic, inelastic, perfectly inelastic, head on, oblique. Everything is clear to you. Now what we are going to do, we are going to make some pairs. That is, we will learn about one dimensional perfectly elastic collision. We will learn about two dimensional perfectly elastic collision and a little bit about inelastic collision. If NCERT book you see, I think they have not talked much about these things, but we are going to study perfectly elastic head-on collision, perfectly elastic oblique collision and a bit about inelastic collision also. That is what is the target of us. If you come to competitive class, some more things we will study in that beyond this. Let us start today with the first collision, which is perfectly elastic head-on collision. Give the heading as perfectly elastic head-on collision. Now the derivation starts. It's long, lengthy derivation. Step by step you write, then only you will be able to understand it. It will take 2-3 pages of your notebook today, but don't try to mug this up. Only if you understand the concept, you will be able to do in the examination. So everybody drop your pens now and listen to me. I will give time for copying. Okay. So what I am doing, I am taking an object having mass m1, velocity u1. Since I am taking head-on collision, its axis is same. So velocity u2, mass is m2. After they collide, after their collisions, they will have same direction, that is v1, and second body is having velocity v2. If you are noticing, I am very careful in writing v like this and u like this. You may say, what big thing I am telling. Today, if you, many have a habit of writing u, v, like this you are having habit, no? It will confuse you. Because so many times u, v, u, v, u, v will you use, you will confuse whether it is u or it is v. So my suggestion from my experience, I am telling you that have a habit of writing u like this, v like this, for this derivation at least. You may think I am sounding silly, but you will understand today after the class gets over why I am saying this. Okay, let us start then. So, perfectly elastic head-on collision. I am going to apply law of conservation of momentum first, which is says that m1 u1 plus m2 u2 is equal to m1 v1 plus m2 v2. Do you agree with me? Here if I take m1 common, I can write u1 minus v1 is equal to, if I take m2 common, I can write v2 minus u2. Do you agree with me? Nothing big I have done, rearrange terms. Okay, let this be equation number 1. Then I am applying as per law of conservation of kinetic energy. Suddenly, what is this law of conservation of kinetic energy? We have law of conservation of energy, we have law of conservation of momentum, but what is this law of conservation of kinetic energy? See, it is what collision? Perfectly elastic, right? I told before some time, in perfectly elastic collision, kinetic energy is conserved. What is kinetic energy before the collision? and after the collision remains same. I told no. Same thing I am going to use now. So what I am going to do? I am going to write half m1 u1 square plus half m2 u2 square is equal to half m1 v1 square plus half m2 v2 square. Do you agree with me? Kinetic energy before the collision, kinetic energy after the collision. Half gets cancelled, and if I take m1 common, what do I get? u1 square minus v1 square, v1 comes from here, and what will be m2 if I take common? v2 square minus u2 square. Any problem in this? I hope no problem is there. Let this be equation number 2. Is it clear up to here? Any problem? If there is any problem, please ask me. No, right? I hope no. Then what I will do equation 2 divided by 1. If I divide 2 by 1, I am going to get to see what m1, what is u1 square minus v1 square? u1 plus v1 into u1 minus v1. Do you agree? Divided by, that's what you have, m1 into u1 minus v1. There you will get m2 v2 plus u2 into v2 minus u2 divided by m2 into v2 minus u2. Do you agree with me? I am dividing this by this here. So this is coming in denominator. Clear? I have written here also, no, 2 divided by 1. Clear? m1 gets cancelled, u1 minus v1 gets cancelled, v2 minus u2 gets cancelled, m2 gets cancelled. Do you agree? What remains finally? Remains finally is u1 plus v1 is equal to v2 plus u2. If I rearrange, I can write u1 minus u2 is equal to v2 minus v1. Do you agree? u1 minus v2, don't you think this is relative velocity of approach? Those who know a bit about relative velocity, they must remember that relative velocity is v12 is equal to v1 minus v2. So here it is u1, velocity is u2. What is the relative velocity of 1 and 2? u1 minus u2. After hitting, u2 will be, v2 will be more, v1 will be less. That's why v2 minus v1 can be called as relative velocity of separation. Please pay attention. This is relative velocity of approach. Obviously, v1 is approaching, u1 is approaching towards u2, and after it collides, it gets separated. It will separate only if v2 is more than v1, isn't it? That's why v2 minus v1. This is called as relative velocity of separation. This ratio of relative velocity of separation by relative velocity of approach is called as coefficient of restitution. So what is the definition of coefficient of restitution? It is what? The ratio of relative velocity of separation divided by what? Relative velocity of approach. Now what is relative velocity of separation? v2 minus v1. What is relative velocity of approach? u1 minus u2. This is the concept of coefficient of restitution. Now you can understand, see how it will become. I said before some time that if it is perfectly elastic collision, I said E is equal to what? 1 I told. It means that v2 minus v1 is equal to u1 minus u2. That's what we have got here. For which collision? Perfectly elastic collision. I said for inelastic collision E is 0, Actually, perfectly inelastic collision I told. For perfectly inelastic collision I told E is 0. Check what will happen if you put E is equal to 0. V2 minus V1 will become 0. So V2 will become V1. That is what I told you also. I told after collision the object will become same velocity. Same thing happened, no? If you put E is equal to 0, V2 became equal to what? V1. And obviously if it is inelastic collision, then V2 minus V1 will be less than U1 minus U2. Common sense this is, if E is less than 1. Are you getting my point? So this is the logic of coefficient of restitution, which is if they ask in examination 1 mark, if they ask in examination for 1 mark, define coefficient of restitution. It is the ratio of relative velocity of separation to relative velocity of approach. Clear? If yes, start copying from here. Now you may be understanding U1, V1, U2, V2, why I told to be carefully taking. You do right, then you will understand more. Copy fast. If anybody has any doubt, you can ask me. Let me know when you are done. Let me know if you are done. Let me know if you are done.
Yes, sir.
Great. Here people done? Fast, fast, fast. Can I go to the next page? Yeah, I'm waiting, I'm waiting. Make it fast. Indumati, what is happening at school now? Which chapter?
Sir, sir is teaching work, energy, and power source.
Okay. So they have not reached this collision topic yet.
No, sir.
Okay, okay, fine.
Okay.
SSM school, what they are doing?
Sir, they have started a system of particles in rotation.
Finished the collision. Great. They taught all these things. Huh?
But it was not clear.
But they have taught these things. Okay. So what is your is Sriniketan, right? What is happening?
I have completed a 6th lesson, sir.
Sixth lesson means you know what? Sixth lesson is what lesson?
System
System
of particles.
of particles is finished. It's going to start gravitation. Very fast.
You told that we'll be having the whole one full volume for term 1.
When term 1 is September?
It starts.
You both are in same school. Oh, classmate. What is your school doing?
So they are going to complete the system of particles. That's all.
That much fast there.
So they are running like very fast.
And then how will you understand?
So this derivation and all, page to page it went, sir. That's sir. Whatever he taught, nothing I was able to get.
Now you are understanding something? Yeah, it should be taught slowly only. I don't know why they are hurrying. That too, they are getting so many classes in a week. I am able to meet you only 2 hours. Okay, whatever. What is any other school remaining? What is happening at your school?
7th chapters are going to complete.
Gravitation going to complete. Okay. I don't know what they'll. I think they'll start 12th early. Yeah. What is happening? Huh? Laws of motion. Which batch you are, man? Which school you are? In some different JE batch you are. That competitive batch. That's because Pulli and all they are not teaching in regular class, no? They are teaching means you are in NEET batch. Yeah, okay. Shall I proceed further? Guys, you want me to complete or not? I'll make it to wait till 10 o'clock today then. Yeah, copy fast. Please, 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 please.
Get that? Could you try again?
Let me know if you are done. Done? Oh, you will let me know. Restitution. I'll write once again. Visible? Sadhana, one more light has to glow actually. Second last switch. Thank you. Can I proceed? This page you wrote? Then this page you write one. What is there you write first? Last? E is less than 1, right? So what will happen? This V2 minus V1 by U1 minus U2, this will be less than 1, isn't it? Because E is less than 1. So if it goes this side, it will become this only, no? I hope you got my point. Done? See, some things you are missing also, don't worry, this board will be there. It's not erasing board. I am going next page. Later you copy, please, okay? Because I want to finish some topics here, please. I am very slow today. I'll send, man, no problem. While going, we take a photo and go also. I'll send a photo to you, okay? I hope everybody has written. If not also, I am going to the next page. Please pay attention. So up to now we have done only 20% now, 80% is still remaining. So please cooperate. Okay, so we have understood that u1 minus u2 is equal to v2 minus v1, right? What we are going to do now, see, I am telling the step by step things to you for remembering the derivation. First, we are using law of conservation of momentum forming the equation. Then we are using law of conservation of kinetic energy forming an equation. Then I am dividing both and getting this relation. After that, my aim will be, from here I will find v1. Easily I can say v1 will become equal to v2 minus u1 plus u2. And I will find v2, which will be u1 minus u2 plus v1. I will find v1 and I will put in that equation and I will find what is the value of v2. So my aim is to find the value of v1 and v2 along with mass. I will explain this to you. Let us do that. So from here I am writing two things. I am writing. One thing I am writing is what is v1. v1 will become equal to v2 minus u1 plus u2. Do you agree? v1 goes this side, this both comes this side. Same way, v2 will become equal to u1 minus u2 plus v1. Anybody has problem in this? Should not have. Okay. Now, this was already 2 I have taken. Let this be equation number 3. Let this be equation number 4. This is equation number 3. This is equation number 4. I am going to insert equation 3 in the first equation, 0th equation, whatever you want to call it. So, I have to change the page. v1 is what? Remember this, okay? v2 minus u1 plus u2. v2 minus u1 plus u2. So, what was the value of v1? Minus u2. This was equation number 3, right? So, what I am doing? I am substituting equation 3 in equation 1. Equation 1 I am writing as m1 u1 plus m2 u2 is equal to m1 v1. Instead of v1 I am substituting what? This one, v2 minus u1 plus u2 plus m2 v2. See, pay attention, this is the point where you will start confusing. So, be in the class, nothing big I am doing. Today whatever I am going to do is basic mathematics, not even integration differentiation, basic mathematics. So, just have attention what I am doing. Now, I am going to rearrange the terms. So, I am going to get m1 u1 plus m2 u2 is equal to m1 v2 minus m1 u1 plus m1 u2 plus m2 v2. Clear? Nothing? I have opened the bracket. Now, m1 u1 is there, m1 u1 is there. I can cancel there, minus plus. It will come this side. So, I am going to get 2 m1 u1. Okay. What else thing remain? This and this consumed. These things are still remaining. So, since I am going to find the value of v2, I will take v2 common this side. If I take v2 common, what I am going to get? m1 plus m2. Okay. This side if I bring this term, then I can write plus u2 common, it will become m2 minus m1, right? What I have done now is just rearranging the terms. Any problem in this? From here, cannot I write v2 is equal to m2 minus m1 by m2 plus m1 into u2 plus 2 m1 u1 by m1 plus m2. Do you agree with me? Anybody has problem with this? This is the equation of V1, sorry V2, isn't it? We got the equation of V2, no? Any problem? Just the rearrangement of terms I have done, nothing else I have done. Same way, in that page, I had V2 is equal to U1 minus U2 plus U1 minus U2 plus V1. V2 was this U1 minus U2 plus V1. Is the equation number 4. I am going to substitute equation number 4 in equation 1. Once again, I am going to do the same thing. Let me use different color. So, M1 U1 plus M2 U2 is equal to M1 V1 plus M2. V2 के बदले I am writing U1 minus U2 plus V1. Any problem? I will open the bracket now. So, it will become M1 U1 plus M2 U2 equals M1 V1 plus M2 U1 minus M2 U2 plus M2 V1. Any problem? Okay. M2 U2, M2 U2. Together I will take 2 times of M2 U2. This side I will take V1 common. If I take V1 common, it will be M1 plus M2. Do you agree? And what remains? U2. No, U1 remains. So, if I take U1 common, it will be M1 minus M2. Do you agree? This went here. So, M1 here, M2 here. Okay. If I rearrange, I will get V1 equation. That will become equal to M1 minus M2 by M1 plus M2 into U1 minus 2 M2 U2 by M1 plus M2. Do you agree with me? Tell me, Mr. Raghav. How minus came here? Plus will come then. Now you are understanding? Plus only will come. I have only wrote minus. Plus is here, no? Clear? Any problem you ask me? Just rearrangement of terms and getting these expressions. My aim was to get V1 and V2 in terms of M1 and M2. I am ended with that. Not over yet, but up to here it is over. Is it clear to you? What happened, Anukirtana? What problem you have?
Sir, like the last step, V2, like how do you get that?
Shall I write one more step? I can write if you want to make it a little more easy for you. What is there? Time only it will take. What else it will take? I will write one more step, Anukirtana. No problem. See. Why I should write? Same thing only I will write. Okay, I will write. So, V2 is equal to U2 into M2 minus M1 plus 2 M1 U1 divided by M1 plus M2. This is clear to you, Anukirtana? I can take denominator separately for both the terms. If it is 2 plus 3 by 6, I can write 2 by 6 plus 3 by 6, I can write no. So, if I am writing separately, it will become M2 minus M1 by, I can write M2 plus M1 also, my convenience. You can write M1 plus M2 also, nothing wrong in that, into U2 plus 2 M1 U1 by, is it clear? Same thinking. The same step I can write there also if you want me to write, not required, no, that is how it comes. It is all about basics algebraic expression solving, nothing big is there. If you are understanding, please copy it fast. Very basic mathematics it is. Yes, Mr. Lalit, don't ask anything. Yeah, tell me, man.
V2 is equal to U1, U2 plus V1.
Which part you are saying? This one?
Sir, after this, substituting 4 above it, substituting 4 in equation.
This one.
First one was not there.
Huh?
Fourth equations.
This one.
Fourth equation. Yes, sir.
This one came from this page, man. I just simply wrote here. V2 is equal to U1 minus U2 plus V1. From here it came. Okay, Lalit?
Okay.
Raghav, copied. This same thing I wrote there also, man. Something else you are copying. Let you copy later, man. Come on, fast. Bad thing is still many things are remaining. Collision is always time taking. Anybody got problem with U1, V1 or not till now? You're writing properly? Okay. You got? Okay.
And even with 1 and 2 also.
See, the thing is, now you are copying, then you're getting problem. Imagine you are doing by yourself. Full derivation. Then what will happen? You pray to the God, huh? Let the exam happen.
Teacher, need to pray to the gods.
Easy to say that. Don't take more than 3-4 minutes, please.
Sir, I have a doubt.
Ask me, Mr. Sri Krishna.
Sir, if the momentum and kinetic energy both are conserved in elastic collision, why the velocity is changing?
Why the?
Travel in the...
See, conservation of velocity and conservation of kinetic energy are not same, Tambi. I am not saying that velocity will be same. I am saying that kinetic energy will be same. Are you understanding, Sri Krishna?
No, sir.
If two objects have same velocity, does it mean they have same kinetic energy?
No, sir.
I am running at 10 meter per second. You are running at 10 meter per second. We both will have same kinetic energy, Krishna?
No, sir. The masses are...
Different, yes. You will have less energy because you are having less mass than me, hopefully. Isn't it?
Sir.
So, here the kinetic energy is conserved, not the velocity is conserved. Half m1 u1 square plus half m2 u2 square is equal to half m1 v1 square plus half m2 v2 square. It means the energy before collision, energy after collision is going to be same. Velocity may not be same also.
Okay, sir.
You are confusing between conservation of velocity. It's not conservation of velocity. It is conservation of energy, not velocity. So, not only Krishna, anybody, don't ever think that if two objects have same kinetic energy, they will have same velocity. No. They may have different velocities also, because mass may be different. Are you getting my point? If two objects have same kinetic energy, it does not mean they have same velocity. Their masses may be different, so they will have different velocities. Are you done? Please make it fast. Take 1 more minute and finish. Please, here. I request.
I found this on the web.
Now, what I am going to tell next after this is very important for competitive classes, not much important for school exams. But let us learn here, no problem. Up to here is what is required in school exam. Derivation of V1 and V2. but I am going to go beyond this, one step beyond this. Shall I? Kirtana, done? Done, right? Online people, everybody is done? Shoaib Ahmed, done?
Yes, sir.
Lalit, how much time? Okay, all of you have written properly, no? I'm going to ask you, I don't remember all these things. I will go to the next page and I'll ask you. Shall I? Lalit?
Oh, 1 minute, sir.
Oh, make it fast, please.
Sir, complete.
Thank you, Mr. Lalit. Yes. So, what we got the value of V? Haran, something you are saying? Ha, Karthik and Tambi, tell me, man. How much time you need, Mr. Karthikeyan? Okay, make it fast. Time is wrong there. श्रेय, सिस्टम का टाइम चेंज किया हुआ है क्या? टाइम डेट सब गलत दिखा रहा है, बाद में चेक करना, ठीक है उसको? हाँ. Karthikeyan, something remaining you write later, please. Okay, I am going forward. Okay. Yes. So, what is the value of V1? Tell me, anybody. See and say here, please. V1 is M1 minus M2 by M1 plus M2 into U1 plus 2 M2 U2 by M1 plus M2. Isn't it? This is the value of V1. And the value of V2 is M2 minus M1 by M2 plus M1 into U2 plus 2 M1 U1 by M1 plus M2 or M2 plus M1, whatever you want to write. Right? Okay. Now from here, I will learn some scenarios. Scenario number 1, that is case 1, about which case I spoke to you now. Truck and the bike today, beginning of the class. Coming to that. Car I told, car and bike, whatever. So, if M1 is much more than M2, that is, two bodies are colliding and the body which is hitting is very heavy and the body which is getting hit is light, like a car hitting a bike, something like that, or a truck hitting a bike, whatever. So, if M1 is much more than M2, then M2 can be neglected. Don't do collision there, man. Already we are okay. So, M1 is much more than M2. What I am neglecting? M2 I am neglecting. If M2 is neglected, what will happen to V1? Check, the equation will change. M2 is 0 now. M2 0, this becomes 0, this becomes 0, it will become M1, M1 gets cancelled, it will become minus U1. And M2 is 0, that's all. V1 became minus U1. Check, everything is right, no? Anything I did mistake? Correct, no? Okay, and what about V2? M2 is 0. So, M2 is 0, M2 is 0, this 2 gets cancelled, minus U2 and here plus 2U1. So, 2U1 minus U2. Check whether I am right. Is it right? What's I Varshini? What is happening, you are wondering? Yeah, M2 is, so, huh? Yeah, thank you. Plus only. That's why I'm asking to confirm. I'm not God here. I cannot be also wrong. Yeah. Correct. This is correct, no? This is correct, right? I hope it is correct now. Yeah, it's correct. So, subcase. In case, I will take subcase. Subcase is if u2 would have been 0. That is, the object which is getting targeted is at rest. Then what will happen? V1 will remain u1 only, but V2 will become what? 2u1. Do you agree? Do you agree? Because u2 became 0. Now this equation gives us the understanding of what will happen in the case of collision of bike and car. So now take the example. Example was, there was a car going at what speed? 60 kilometer. 60 only I told, no? 80 I told, okay. 80. And there was a bike at what speed? Going at 60 kilometer per hour. If they collide, they will collide obviously. After collision, what will become V1? U1. It means whatever velocity, this is what U1 is, no? And is U2. So after collision, car will have same velocity, it will not change its velocity. Why should change? How can bike affect a car much? And what will become V2? V2 should become 2u1 minus u2. So what is 2u1? 2 into 80, 160. 160 minus 60 is how much? It means bike was going at what speed? 60 kilometer per hour. Because the car has hit the bike speed became how much? 100 kilometer per hour. Thrown. Injury is definitely possible. What possible? It will happen. Second case, car, what speed? Same, 80 kilometer per hour. Bike, 0 at rest. What will happen to V1? Same 80 kilometer per hour. What will happen to V2? What will happen to V2 here? 2u1. Compare which is more. Which is more? It means when the object is already in motion, if it is getting hit by something, with how much velocity it was running, it helps in reducing that much impact. 60 was there, no? So it became 160 minus 60, so it became 100. It was having 0 velocity initially, so whatever it gave, it became double of that. So if the bike is at rest and the car is hitting at 80 km per hour, the impact will be how much? 160 km per hour. But if, U2 is the velocity of the bike. U1 is velocity of car, U2 is velocity of bike. In first case, bike was moving at 60 km per hour, car was going at 80 km per hour. In second case, car is going at 80 km per hour, bike was at rest. So U2 is 0. Are you getting what happened? Which case will have more injury? Second case, in the rest case, which most of you did not say except Sadhana and Soumya. Because common sense says that if you are moving only, it will have more injury, but that is not the real case. Are you getting why? Is it clear to you? This is one scenario. I can erase this also. Let us see second scenario. Second scenario is, there is possibility that M2 is much more than M1 possible, no? Like a ball thrown on a wall. Wall is huge, big, and ball is light, isn't it? So the second possibility is, if case 2 I am writing here. What is case 2? Case 2 is if M2 is much more than M1. What will be neglected then? M1 will be neglected. So if M1 is neglected, see and tell me what is the equation of V1 and V2? What will be V1? M1 is 0. Now it will become minus U1 plus 2U2, isn't it? Check. And what will be V2? That's all. Isn't it? V2 will become U2, V1 will become 2U2 minus U1. Now let us take example. There is a wall moving at practically not possible, theoretically anything is possible here. Theoretically I can fly 2 meters per second. Imagine a big wall made to move on the rails. Possible, no? Like a rail is moving, heavy only. And there is a ball coming towards it at 10 meters per second. Okay? Ball comes and hits the wall. What will be the velocity? This is the value of U1. This is the velocity of U2. After the ball hits, the velocity of the wall will remain same. Obviously, it will remain same. How can ball increase or decrease the velocity of wall? So, V2 will be same, U2 only, 2 meters per second only. What will happen to the ball? It will become 2U2 minus U1. So, 2 into 2 will become 4. 4 minus 10 will become minus 6. Isn't it? Minus 6 is what? It will go in the opposite direction. Are you getting what I am trying to say? It will happen or it will come back to you. And second case, if this would have been at rest, it is 0, U2 is 0. Then what will happen to, if U2 is equal to 0, what will happen to the equation? V1 will become equal to minus U1 and V2 will become equal to 0. Do you agree with me? Do you agree with me or not? It means that the velocity of first object will become minus of it. Throwing at 10 meters per second, it will come back with 10 meters per second. And second object will remain at rest itself. It is a real life scenario. Having a ball, throwing, it will bounce back to you. If it is elastic collision, it will come back with the same velocity. Isn't it? I hope something you are understanding. These things are very conceptual things which will directly come in the competitive examination. Not maybe in the school, but it will come in the competitive examination. There is something called as case 3 also. What is that? Case 3 is if both are same mass. If M1 equal to M2, possible, no? Like billiards game or carom board game. Carom board we have a striker which is having more mass. But in billiards game all the balls will have same mass. So if both the masses are same, then what will happen? This is quite possible scenario. It will become 0. What will be V1 then? This will become M2, 2M2, it will become U2, isn't it? And what will happen to V2? This will become 0 and this will become U1. Exchange of velocities will happen. That is what happens actually in billiards. But in billiards what happens? In billiards, the U2 is also 0 always, isn't it? The ball that you are hitting is already at rest, it is not a moving ball. If U2 is 0, then what will happen to V1? It will become 0. What will happen to V2? It will become U1. Real life scenario. If you are hitting the ball with your, what is it called that? Rod, what do you call that? Stick. Then, if it is a perfectly elastic collision, your striking ball will come to rest and the ball that you are hitting will go inside that hole. It happens, you see the games you will realize, it happens really also. It will come to rest, it will go in motion because all its energy will be transferred. Same thing happens here, V1 becomes 0 and V2 become U1. So whatever velocity it was having, it will transfer it to the second body. Is it clear to you? These are the three scenarios if M1 is much more than M2, M2 is much more than M1 and if M1 is equal to M2. Is it clear to you? If yes, please copy fast. Yes, Mr. Lalit.
Sir, I can understand third case.
Third case, I have taken both the masses to be same. Did you understand how this equation came, Lalit? You have problem in this equation or the example that I gave to you?
Equation.
M1 is equal to M2, Lalit. So M1 and M2 are same, they will get cancelled, no yaar? It will become 0, right?
Sure.
And this term 2M2 by, they both are same. So M2 plus M2 will become 2M2. 2M2 gets cancelled, it will become U2, right? Are you understanding, or shall I write it for you, Lalit?
Yes, sir.
Same way in V2, these two are same, it will become 0. And here 2m1 by m1 plus m2. Instead of m2, I can write m1. So 2m1 by 2m1 will become cancelled, it will become u1. Is it clear?
Okay, sir.
Yeah, that is basic common sense. Please finish writing all the 3 cases. I couldn't finish what I thought of finishing. Is it done? Then all 3 cases done. Can I proceed further? Sai Varshini,
Oh, 1 minute.
make it fast, Harin. Shall I? Harin Krish, done?
Yes, sir.
Okay. I am erasing the board. Yeah. So now next heading is kinetic energy transfer during the collision. Kinetic energy transfer during this perfectly elastic head-on collision. Don't write like this in the examination and all, okay? It's not a case, it's the value of how much kinetic energy is transferred. NCERT book will not talk about this, it will come in competitive examination only, but NCERT has an example. In that example question, they have talked about this. They have not talked this concept in the class, in the context, but they have given an example. In that example, they have used this concept. So I am teaching this concept to you. You will not find this topic in the book, I think. Okay? So kinetic energy transfer during the perfectly elastic head-on collision. Please pay attention. Please pay attention. So we know what is happening. Well, there is an object of mass m1 having velocity u1, another object mass m2 having velocity u2. After they hit each other, then the m1 has a velocity of how much? v1, m2 is having how much? v2. This is what is happening, scenario. So, what is, if you see deeply, it has some energy, and obviously, if it is hitting this body, some energy is getting transferred from the first body to second body. We are going to calculate how much energy is transferred from first body to second body during the collision process. So, what is the kinetic energy transfer, in simple words if I say, what is the kinetic energy of source? It will be half m1 u1 square. What is the kinetic energy of target after it hits? Half m2 u2 square. So, what is the change in kinetic energy? How much is that? Half m1 u2 square minus, somewhere something is wrong. I guess, yeah. Please, one second. See, kinetic energy of source is half m1 u1 square. After it goes and hits the second object, what is the kinetic energy? This was before the collision, right? What is the kinetic energy after the collision of the source? It will be half m1 v1 square. Do you agree with me? See, it had some energy, it hit the second object, it lost some energy, and remaining energy it had. That is only half m1 v1 square. Are you getting my point? It had some energy, it hit the second object, so its energy reduced. So, if you want to find how much energy got transferred, I should subtract what is the energy remaining and what is the energy existing, difference of that. I will repeat and I will explain once again to you. I am having 100 joule of energy, okay. I am going and giving 60 joule to you. How much I will remain? 40. So, if I know my initial energy is 100, my final energy is 40, how much I transfer to you is 100 minus 40, 60. So, initial energy was half m1 u1 square, final energy is half m1 v1 square. So, how much energy was transferred to this object? Subtraction of both. So, kinetic energy transferred will be how much? Half m1 u1 square minus v1 square. Do you agree with me? How much energy it had and how much energy it had after collision. Subtracting both, I am going to get what is the energy transferred to the target by the source. This is what I am calling as delta Ke, change in kinetic energy. Delta Ke. If I want to find what is the fractional decrease, from first chapter this things comes here, fractional decrease. Always remember, whenever writing fractional, it means change in something by its original value, Ke initial. So, it will become, how much is that? Half m1 u1 square minus v1 square divided by half m1 u1 square, isn't it? This is the fractional decrease. So, half m1 gets cancelled. Fractional decrease means what? Delta Ke by Ke. So, I get the value of delta Ke by Ke as what? I get the value of delta Ke by Ke as, what was that? u1 square minus v1 square by u1 square. Do you agree? Or I can write 1 minus v1 by u1 the whole square. Can I write like this? 1 minus v1 by u1 the whole square. That is the value of fractional decrease in kinetic energy. Now, I can further solve it in terms of masses. How I can solve? I know the value of v1, right? What is that? Let us write it here. Since v1 is equal to, what is that? m1 minus m2 by m1 plus m2 into u1 plus 2 m2 u2 by m1 plus m2. If I assume second object was at rest, if u2 was 0, to make it simple, if I am taking second object at rest itself, then what will be the value of v1? It will be m1 minus m2 by m1 plus m2. I am bringing u1 down like this. Equation number suppose some 1, or I'll take it as 2, this take it as 1. So I am putting 2 in 1 now, because I am having v1 by u1 value. If I put it there, then I will get delta ke by ke, which is substituting 2 in 1. What I am going to get? I am going to get 1 minus, what is v1 by v2 the whole square? Sorry, v1 by u1 the whole square. It will become m1 minus m2 by m1 plus m2 whole square. Are you getting? If you want, you can further solve also. Further solving, it will give me delta ke by ke is equal to 1 minus a square plus b square minus 2ab divided by a square plus b square plus 2ab, right? If I put it there in the minus, it will become m1 square plus m2 square, this is in bracket by the way, don't forget that, plus 2m1 m2 minus m1 square minus m2 square plus 2 m1 m2 divided by, the second write as m1 plus m2 the whole square. Because this 2 gets cancelled, this 2 gets cancelled, I am going to get finally my, I am writing it here, okay, I am writing a different color. I am going to get delta ke by ke as 2 plus 2 become 4, 4 m1 m2 by m1 plus m2 the whole square. Is it clear to you? This is the equation. Anybody has NCERT book here? NCERT volume 1 book. This is the equation of transfer of kinetic energy if two objects are undergoing perfectly elastic what collision? Head on collision. Actually, they have see, in the example question, there is a question in the NCERT book, page number 85, if you are there in the online, slowing down of neutrons. An example is there. In that example, see what they have used suddenly. While the fractional kinetic energy gained by the moderating nuclei is 4 m1 m2 by m1 plus m2 the whole square. If you are solving the studying the book, suddenly you will think how it came. No, nothing they have written. What they wrote? 4 m1 m2 by m1 plus m2 the whole square. That is how it came. It is the energy which is transferred from one body to another body. And how we have found it is clear to you? If yes, you can copy it later because time is almost 9 o'clock. This copying you can do by seeing the, I will share the video link in the group. Already I have shared, I think. So you can go home, see that part of the video alone and take the notes later. But don't forget to take the notes before you come for the next class. Before joining for next class, please finish taking the notes. A small topic is remaining, which is about perfectly elastic oblique collision, and then we will start system of particles and rigid bodies. Tomorrow's practice class, I will give questions based upon collisions also. Okay, work energy and power worksheet will be given. Solve that and you will get confidence in how the questions can be asked in the examination. Okay, bye bye, take care, good night. We will meet again in the next class.